Hello everyone, I'm Desiree Chong from class G3. Welcome to my channel. Today I'm going to show you how I arrive at my answer for project 1. So here's my algorithm. Firstly, I create a 2D array to represent a box, and then I will set the longer side of the box to be the width of the box. And then I will sort the given items in ascending order, so the smaller items will go inside the box first, because here we want to put as many items as possible into that one box. Then after that, I will just iterate through the sorted array of the items, and then for each item I get their height, width, and ID. Here I'll also set the longer side of the item to be the width, same like just how I did for the box earlier on. So for every item that I am going to insert, I will check that if it can fit within that particular range of spaces. I'll go from the top left to right, and then just left to right, left to right. So if they are empty, if all the spaces within that range will be empty, I'll just put the item in and mark those previously empty spaces with the item ID. So after that, I'll just put the item ID and the coordinates into the return array and repeat this whole process for the following items. So my complexity for my algorithm will be as follow. I've copied a few snippets of my code over here, those relevant ones. So over here, the first nested for loop, when the outer loop executes for n times, the inner loop will also execute for n times. So over here, the complexity will be O(n) squared. Same for the one inside for the second nested for loop inside this loop. It will be n squared also. So the entire complexity so far will be O(n) to the power of 2, and we assume that all the if statements are true because you want to get the worst case. And then the rest of the code will be less dominant, so we just drop it, and the complexity of my entire algorithm will be O(n) to the power of 4. Thanks for watching, and here's my references for the project.